Hello and welcome to my EEG brain analysis application. This program was created to provide a tool for educational strategies to examine the mental load of students, which includes attention, emotion, and cognition, in order to recommend a pedagogy for a specific learner. To use the application, simply click the Start Application button and wait for a second for it to process. Then you are prompted to this page that allows you to import your dataset. Just allocate the location where you save your datasets. In fact, this application can process all the datasets of the learners, or you can process it individually. Now the application is starting to import the datasets consisting of 14 electrodes. These electrodes are in charge of capturing brain signals. Then click on the Save button to save the datasets, of course. Then click on the Process Datasets button and configure the windowing of the signals to 20 for the Wells periodogram method. Then set the high cut frequency to 100 Hz and 4 Hz for the low cut for the bandpass filter. And then we will be also setting the ideal frequency to 100 and the frequency sample to 5000. Then we disable the PCA since all electrodes are considered. And let's wait for this to process. Let's look the process output of the datasets by clicking the pre-process graph and starting with the raw EEG datasets. As can be seen, there are 14 electrodes and each electrode has some spikes indicating that the learner's frequency signal changes from time to time, either decreasing or increasing. To check the EEG signal, all you have to do is just click on the label. So we have here the task exercise 1 to exercise 5, then we have machine problem, the reading 1 until to reading 5. So okay, as you can see, you can also download the graph, okay, by clicking on this button, download graph, then you can save it to your local device. Next is to reduce the noise of the signal. So we implement here the panning window. So this particular algorithm will reduce the leakage of the signal interference, thus it closer to ideal or inner zone of the signal. Furthermore, it reduced the non-integer signal values to 0. Next, let's proceed to the fast Fourier transform. So as you can see in the graph, so we have here the y-axis shows the frequency and the x-axis shows the time domain, and the red graph that are the magnitude of the channel, and the blue line is the amplitude. Next to this is the implementation of the bandpass filter, because this application will only concentrate between 4 Hz to 100 Hz. So as you can see, we apply here the Wells periodogram method. This is to reduce the variance of the signal instead of analyzing the entire signal. And the window applied here is 20 seconds. Okay, so let's proceed to the power spectral density. As you can see, so you can check the recorded frequency bands. Um, let's check if there's a value for alpha here. So as you can see by clicking the alpha bands, So you can now check if the bus is increasing or decreasing its value. Okay, so that's the graphical representation. So in this application, you can also see the values. Okay, let's click on the summary and let's know what would be the recorded frequency bands. As you can see in this graph, so this particular student recorded a higher alpha value, meaning these students have a normal mental load while performing exercise 1. So you can also check the frequencies by clicking on the button, uh, starting with the raw data sets, absolute power, bands, gate, and also you can generate the CSV for further analysis. So this application allows you to import. Okay, um, I have already here the record of the student. So I just import the data. So as you can see, so these are the score of the students in performing the task. So we will use that for correlation and regression. Then we also import the verbal expression of the learners while performing each task. Since the data are now imported, then let's proceed to the analysis and let's classify the data sets by configuring the classifier. So just click on this configure classifier. As you can see, we have algorithms to choose from, but for this demonstration, we will configure SBM with 70-30 ratio and random state of 0. So we can train this model and select the function. So we have no kernel, Gaussian, sigmoid, and polynomial for SBM. Let's see which among the functions provides higher accuracy. So let's train the model. And here, so to show you the result, okay, since we're done training the data set, so just click on that label. Then this is the confusion matrix. Then you can also check on the tables. So this is the tables, as you can see. So the accuracy score for this particular data sets for specific learning is 47%. Okay, then you can also show the graph for each kernel, which among the kernel provides higher accuracy. As you can see, both no kernel and Gaussian kernel, okay, have the same accuracy score. Before we proceed to the analysis, let's check first the summary report of this particular student. As you can see, the alpha value outperformed the other frequency bands. So therefore, so the selected frequency bands here is alpha. Then you select which among the tasks to correlate. Like for example, reading 1 and exercise 1. Let's see. Okay, the correlation analysis for this particular variables. So let's wait for this to generate. And so we have here, there are 3 types of correlation, but in this study we'll be using the person correlation. So let's check the person correlation. So this is the graphical representation based on the scatter density. Then between the reading 1 and exercise 1. So for the result of the correlation based on person correlation, that reading 1 and exercise 1 have low correlation. Moreover, you can also make correlation analysis. So, like for example, the exercise one, and if you remember, so I imported the score. So let's correlate if the exercise brain activity and the score or the performance score are correlated. So based on the result, the result shows no correlation between exercise one and reading score. Okay, so let's proceed to the regression analysis. So for the configuration, so that set the random state to 0, then the training is 70 and the testing is 30. Then we select the dependent variable for this because we would like to know which among the tasks from reading, exercises, and machine problem tasks have a significant impact to the performance score of the learner. So let's wait for this to generate the result. And since the alpha value is our basis, because this provides the higher value than other frequency bands. So let's see what would be the result. Okay, so of the regression. So just click on the alpha bands and click on this view pedagogy analysis. Then it will show you a computed regression. Okay, as you can see, looking at the p-value, all of the tasks have no significant impact to the performance score of this learner. So, meaning all of these tasks should be considered to recommend a pedagogy, but we would like to rank it. The top three here is exercise 2, uh, reading 3, and reading 5. So the recommended pedagogy for an exercise is integrity, and for the reading task is inquiry based. The recommended pedagogy is based on the rule base set by the experts. In addition, this application will also provide you the fast Fourier transform of the EEG signals, so how it will be processed. So as you can see, from the row FFT to the bandpass filter to the Hanning window, and from Hanning window the bandpass filter and bandpass filter to Welch, going to see if there are changes and transformation. And to measure this by looking at the peak signal ratio and the mean squared error. So this is the entire application of analyzing the EEG brain signals, in which algorithms are integrated to process the signal and analyze it. This application is beneficial for non-coders who would like to investigate the brain signal, which will be used for educational purposes.